Welcome to the CNC Mill 1 for the Tormach CNC 770MX, I believe, is the model number, at the EXP Makerspace. Um, Many of you have taken this training and have asked for a reference. The intent of this recording is to be a model training for our student worker trainers and to serve as a reference for those of you who have already completed the training. This video is not a replacement for the in-person training. You are welcome to look at it beforehand. You do not have permission to run the machine until you complete the in-person training and demonstrate that you've run your own CNC program from start to finish. Cool. That said, let's jump into it. So, at the beginning, trainers, you're going to introduce everyone to yourself. You're going to introduce yourself. My name is Paul Carson. I use he, him pronouns. I work at the EXP Makerspace. We're going to do some CNC mill training. Then you're going to talk about the Tormach CNC Mill. You're going to discuss the axes of the CNC mill, which way they go. Point out the spindle, the tool changer, and the vise. Describe how they all work. Discuss the hazards involved. There are a number of hazards. The most prominent hazard is flying debris. This machine spins a piece of tungsten carbide or high-speed steel tool at up to 10,000 RPM. Flying debris is the most common hazard. Safety glasses are required. Safety glasses are required at all times in metalworks. This machine also cuts metals, plastics, and composites. All of those materials will shed small particles that are sharp. They are dangerous to inhale and can permanently damage your eyes. Cut edges will have raised thin metal edges. They're called burrs that are sharp and can cause serious cuts. At this point, you want to demonstrate how to test to see if an edge is sharp. I have a piece here. Your finger should run perpendicular to try to pick up a burr. Do not run your finger along the edge like so. That's how you slice your fingers open. Ask me how I know. Hearing protection is optional. We offer hearing protection, both foamies and over-ear hearing protection, generally when machining. If you're wearing hearing protection because the machine is loud, you're fixing the wrong problem. It will be like, brrr, but if it's really loud or there's a really high frequency component to it, you may need to change your machine settings. Using the tools in our library with the settings in our library, that should not be an issue. Never put your hands in between parts of the moving machine. The machine has no force feedback and will happily squish or stab soft parts of your body in between a bunch of sharp metal stuff. Likewise, do not attempt to run this machine in tandem with a friend because you cannot communicate fast enough. That is a recipe for getting hurt for the friend who has their hands in the machine. Cool. With the safety stuff out of the way, the next thing to do as a trainer is to start a Teams chat with everyone in the training. This does two functions. One, it records everybody's name in case you forget, or you forget to ask them at the end. You need to give everybody credentials at the end. It's an important detail. The students are coming there for the credential. They want to learn how to use the machine and they want to get permission to use it. And the way that we validate that they have permission to use it is by issuing them the credentials. It also allows you to share the versions of the files and documents that we're going to use for this training in a way that's convenient for everyone. So you want to start a Teams chat with everybody in there. Get their names. Tell them it's nice to meet them. Do your best to talk to them by their name. If you're not sure how to pronounce their name, ask. Cool. In that chat, you're going to share the link for Fusion 360 for education if they don't have it. I'm going to post that in the description of this video. The EXP Makerspace Tormach tool library for aluminum. And the file that they will be working on, which will either be SoftJaws for the Tormach or SoftJaws for the 4-inch Kurt Vices and the Haas. At the time of the recording of this video, we have switched from Tormach SoftJaws to Haas SoftJaws. I think it's a better example because it's a different part, although it's very similar to the one that's in the example. Also, we need Haas SoftJaws and we have done Tormach SoftJaws. So we've been running it for a while. We may switch back. Cool. The file that you're going to send them is the one that says share this one, not the one that says not for sharing. The one that says not for sharing has all the example code in it. The one that says share this one may have one set of example paths in it. We're going to talk about that when we open the file. You also need to send them the link for our post processor. There's a special post processor for the EXP Makerspace, which, among other things, moves the vise out of the way when you change the tools, which makes it much harder to snap the end of the probe off during a tool change. We made it special for us because before it was real easy to snap the end of the probe off during the tool change. Talk about that, explain why we're doing that, and give preview to talking about how the probe works and the cost of the probe tips. If the patrons break the probe tips while moving the probe around, they bought a probe tip. The tips cost $75 a piece at this point. It's unfortunate, but we had students who broke a ton of probe tips. It got real expensive. So you got to tell them right out of the gate at the training. Okay. Now we're going to move into the CAM, and I'm going to open this file. I'm going to talk about both what we're doing and why we're doing it. Let me share my screen. Switch to Fusion. Here we go. I'm in Fusion. In the Tormach 1 training folder, there's a file for the 4-inch Kurt SoftJaws, a SoftJaw Tormach, and a share this one SoftJaw Tormach. You want to download the share this one and send it to everybody in the Teams chat. You also want to take a look at the script for the training and send them the files in the links. Those will be for reference in this video or below this video. Cool. So I'm going to open my example SoftJaw Tormach. And this has a bunch of setups in it. And you might delete these. Sort of doesn't matter. Cool. This is the SoftJaw for the Tormach. The first thing that we need to do, you should talk about SoftJaws at this point. Why are we making this part? What's it good for? SoftJaws are great for a number of reasons. One, if you hit them with the tool, they're unlikely to break because you're probably machining aluminum. You're certainly machining aluminum if you're using our tool library, and you're not allowed to use other tools that are not in our tool library. They also allow you to machine a negative of parts that are not square so that you can hold a round or kidney shaped or whatever arbitrary shaped part in the SoftJaws. Super duper useful. Great. I'm going to clean this up a little bit. So do it. Highlight all these and I'm going to delete them. And I'm going to make a new setup. So a setup defines the work coordinate system, which is how the axes of the machine are related to the axes of the part. So it's the orientation of the part in the machine, the size of the stock, and it contains all of the machining operations that you're going to do. So it's everything that goes into making a CNC program. The setup is the folder that contains it all. I'm going to make a new setup. And it's going to open up this ribbon command here on the right. I'm going to get rid of these files for a moment. And we're going to move through these tabs. The commands for Fusion 360 CAM all look like this. They give you sort of a ribbon-shaped window, and there are a bunch of tabs in it. And you move generally from left to right. The first tab of the setup is called Setup. And the first thing that it asks you to do is a machine. One thing I'm going to do here, which I think is useful, is if you hover over any of these buttons, it will tell you what they do. In this one, it lets you select a machine. If you must, what I tell everyone in the training is if you must select the Tormach to simulate the Tormach, you can do that here. I don't, because I find that all it does for me is slow down my simulations. The operation type, we're doing milling. So you can do milling, turning, cutting, or additive. Did you know this thing has a FDM 3D printer slicer in it? Pretty cool. But we're doing milling today. The next thing is the work coordinate system. So this is how the part is oriented in the machine. The way that you view this, you're going to see it, and you're going to move the axes around so that they're on your part the way you're going to put the part in the machine. You need to choose an orientation for that. I always choose Z-axis plane and X-axis unless I can't because of the geometry. That's because it's first on the list. They all do what they say they do, and you're welcome to experiment with the other ones. But I'm going to pick Z-axis plane and X-axis. The Z-axis, it's the next thing it wants me to do in Fusion, the next thing it expects you to do in CAM, it will highlight in blue. So it's going to ask me which surface is the Z-axis normal to, and I'm going to pick the top of my part. So that points the Z-axis away. The spindle will be going down into the part. That's what I want. This is the top. The X-axis is the long axis of this part. If I pick an edge, it will make the X-axis parallel to that edge. If I pick a face, it will make the X-axis normal to that face. Normal was pointing out of the face. So if I must pick a face for the X-axis, I would pick the right side, and that's going to pick X off to the right. Okay. Demonstrate the right-hand rule. This is tough in the screen, right? But X, Y, Z. Likewise, when it's in front of you, it's easier, right? X, Y is in and out of the screen, and Z is up, down, like this. That's how it's oriented in the machine. If the X-axis is pointing the wrong way after I pick an edge that's parallel to the X-axis, you can flip the X-axis with this flip X-axis button. I don't need to. It's pointing off to the right. Looks good. The origin needs to be a stock box point. There are a bunch of options here. So you can have a model origin where you define it in the model. That's pretty rare. You can have a selected point. So say you had an existing hole in the part and you were going to locate off that part, you could put it at the center of that hole. The model box point is a corner of the model. So you're putting a new feature in a part with no extra stock. Like you have a thing and you want to add a hole to it. You could do that with the model box point. Stock box point is the outside of the stock, and this is the piece of the bar stock. And at this point, you're going to hold up the bar stock and talk about, I'm taking this thing and has all this material on the outside, and I'm turning it into a finished jaw. There are a bunch of finished jaws in the shop. You should also hold one of those up. Show them. Explain where the stock is. Stock box point. Then I can pick a box point, and I'm going to pick the back left top. Why is it the back left top? Because that's my personal style. As an arbitrary choice, you should choose to do it the same way every time, unless you have a compelling reason not to. Because I wrote this training and I like it in the back left right, or back top left, that's where I'm going to put it. Back top left. Cool. The next thing is the model. So the model lets you define which parts. I keep picking the sketch, which is not what I want. I want the box. The model lets you define which parts in the file you're going to machine. If there were multiple bodies in here, I could exclude some. This part only has one body, so it's sort of a moot point, but this is really useful in the CNC router in particular. And the fixture, if you had, say you had a really cool fixture for this thing, you're making a special part, you have a cool fixture for it, you can model the fixture, that's great. You can then identify the fixture so that you don't machine your fixture, because that's a bad day at work when you cut up the fixture that you spent a long time making to make your part. Cool. The next one is the stock. There are a couple ways you could make the stock. You can do a fixed size box. So you have some X width. You key in the sizes of the box. You're going to make this out of a piece of bar stock. The piece of bar stock is 5.5 inches long by 2 inches wide by 1 inch high. And you can choose, is it in the center? Is it in the center in X? Is it in the center in Y? You could also pick offset from one side or the other. So you could like move it around, right? I could make this 0.05 and take all the material off of this side versus this side. Don't do that. We're going to leave it in the center, right? Center. Cool. You could also choose a relative size box if you don't know exactly how big it's going to be. But generally when you're machining, you're going to choose a fixed size box because you know how big the stock is. You pick it. Generally, you're going to design the part to fit nicely within some nominal size of stock. The last one is the post-processing tab. In this tab, you name your program. I'm going to name it SoftJaw. Today's date is 26/03/25. The Tormach will take a text string. You can type whatever you want in there. The Haas machines require an integer. So you got to put in a number. It's 4 or 5 digits, depending on if you're turning or milling. 4 for turning, 5 for milling. The program comment is the first line of code that talks about what it is. Training video G-code. Okay, the machine WCS. The WCS offset that we're going to use is 1. This is a straight up magic number. It's not actually a magic number. It does a couple things, but for the purposes of most people taking this training, this is a straight up magic number and you're going to name it 1. And the reason that you name it 1 is that this outputs G54 as your work shift, work offset, work coordinate system. I forget what it's called in G-code. There are multiple places you can put the origin in the machine, and you can identify them differently with different work coordinate systems. I'm going to call it so it's consistent with the CAM. They're identified by G codes that you call in the program. So there's G50, G53 is the machine coordinates. G53 you can't reset. And 000 is in the top back right where the machine goes home. G54 is the first one. It's the most common one. It's the one most everybody uses. If you have more than one, you can use G55, 56, 57, 58, and 59. And there are just other places you add the origin. So you could have one origin, G54 origin, and one and the G55 origin another. This is a great opportunity to point at the 2 vices in the Haas mini mill that are next to the Tormach and explain how you might have 2 different work coordinate systems and you'd identify them differently and you could run them in the same program. Anyway, 0 and 1 output G54. 2 outputs G55, 3 is a G56, and so on until G59. There are more after that, and they're different depending on the machine. I actually forget how they're identified in the Tormach, but there's probably like 256 of them somewhere. I forget what they're called. You can look them up in the work coordinate menu on the machine. Cool. That's okay. If you have more than one, you want to click this. And there's more than one, and you can change them. But we're not going to do that. Hit OK. Now I have my new setup. I talked for so long that the iPad that I'm reading from for the script turned off. So give me just a moment. Got to type it correctly. Okay. The very first thing we're going to do, now that we've made our new setup, it's ready to hold our machining operations, we're going to do a facing operation. So a facing operation takes an end mill and skims across the top and makes it nice and flat. 2D face. It's the third one. We're going to select a tool. You probably don't have the tools loaded yet. So we're going to select a tool. And then in here, there are libraries. I have my cloud libraries. There are hub libraries. In cloud libraries, you can import libraries. And then you put the file that we sent. You put the file, have everyone in the training, put the file that you sent them that has the tools into their tool libraries, and then they can use the tools in the tool library. I don't need to do that. I have it in my cloud library. I'm going to use Tormach 1100 MX AL I may have outdated ones. Tormach 2. Sure. I'm going to download it from the training script. Make sure that I'm using the right one. I'm going to download that, both the post and the tool library. Cool. And I'm going back to CAM. And I'm going to import a library, add this one, and I'm going to rename it so that I know which one it is. 60325. Great. Then from this library, I need to select tool 4, which is the largest end mill that we have. The Tormach isn't super powerful. So in order to run it at high speed, where it'll go to 10,000 RPM, but we have it in high gear and it's not really torquey. So the largest end mill that it will reliably turn is a 3/8 end mill. You can do facing with larger ones. It's really normal to do facing with a great big wide end mill and take a really light cut. But 3/8 flat is what we got in there. There aren't a ton of tool pockets, so we're using it. Because it's from our library, all the speeds and feeds are all set already, and that's going to work fine. In multi-axis, we don't have multi-axis. It's only 3-axis. Geometry, the next tab is geometry. It's going to show you the stock. It's going to show the outline of the stock. That's cool. The heights. Talk about what all of the heights are and what they do. You can hover over them and it will explain what they are. Excuse me. Right. So the clearance height is the highest height. That's where it moves to move around in X and Y. The retract height is where it stops feeding at a feed rate and starts rapiding. So it'll feed up at a known feed rate, and then it will rapid as fast as it goes. There are two kinds of movement. We're going to talk about those in the G code. The feed height is related to the top height. This is when it's going down. This is where it stops rapiding, going down, and starts moving at a feed rate. The top height is where it starts cutting, and the bottom height is where the tip of the tool is relative to your geometry. There is an offset, and there are times we're going to offset that, but for facing, we don't. We just want it to be the model top. In passes, which is the next tab, you could change the pass direction if you want. You don't need to. You can change the pass extension. It is useful to change the stock offset. So this adds extra space. Gotta hold my hands right so the camera can see it. It adds extra space around the part to make sure that you cut the whole thing. So it may take the first pass and have the tool just go right along the edge. And if your edge finding wasn't 100%, it'll leave like a thick burr knife edge there. That's sort of a hassle. But if you do a stock offset, it'll take all that off. You don't need to do multiple depths. You don't need to do stock to leave. The linking is how it moves in and out of the part. For facing, generally, you don't need to change this, although you could. Hit OK. And it's going to make a preview of the path. There it goes. When it makes this preview of the path, it's ready to simulate. If I want to simulate it, I can right-click and hit simulate. I can highlight it, and simulate is in actions, simulate. And then I can see an animation. It's going to come down and cut across the part. Oh, this is simulating everything, which is not what I wanted. I only wanted to simulate this face. Great. That's why you send them to share this one that doesn't have as much stuff in it. It doesn't have like 40 trainings worth of setups. Okay, for the setup, you can change the speed with this slider. If you want it to show you the stock being removed, you have to hit the stock checkbox. If it's the first time you've done this, the stock checkbox won't be checked. So everyone's going to be like, why doesn't mine look like yours? And it's probably because the stock checkbox isn't checked. Cool. I always try to do stuff here, and I forget that I have to hit exit simulation. You have to hit exit simulation to do more toolpaths. Great. Sorry. Okay, the next thing that we're going to do is to clean up the ends. So we've done the face. It's nice and flat. We have a nice flat Z reference. That's cool. It's ready to go. The next thing we're going to do is clean up the ends. So we're going to do that with a 2D contour. 2D contour does a couple things. Actually, it doesn't do a couple things. It only does one thing. It follows a path. If you only know one tool path, it's contour. Follows a path. It's the most useful one. It's great. It's the thing everybody has CAM to do. Okay. It's going to inherit this tool. We're going to use this tool for everything in this training. That's okay. We're still only doing 3-axis machining. Now, in the geometry, for a contour, you need to pick an edge. Do not pick a face. It won't work the way you want. You must pick an edge. And you want to pick the bottom edge of whatever you're cutting. So I'm picking this bottom edge, and then it's going to show an arrow. It's going to highlight the whole thing, and it's going to show me an arrow. The arrow shows me the direction of the tool and the side of the path that the tool is on. Now, if I go all the way around, it's going to default to all the way around if it's a closed loop. I don't want to go all the way around because that will cut it out of the vice jaws. I only want to cut the end. So I can double click the chain in the geometry and the contour selection here, and I can switch to open chain and hit OK. Or I'm going to do the one on the other side too. Oh, it defaults to open chain. Or I can click on it again and it will give me the selection, and then I can choose open chain and just pick that edge. Just pick that edge. And I can shift select to get rid. No. Ah. Okay. I have to do these as two separate ones. That's okay. Ah, now it's giving me a closed chain, but I want an open chain. So I'm going to click it, choose open chain, hit OK. In this menu, I can extend them. So I could make this, I can have a start extension or an end extension. We shouldn't need to do this for this one, but it's worth noting because there are times that it's useful. Say OK. I don't need any tabs. I don't need rest machining. I don't need stock contours in the heights. I need the tool to go all the way through the part, and I don't want it to leave an onion skin or burr on there. So I want it to go below the selected contour by 50 thousandths of an inch. That's magic number 2 for this training. 50 thousandths of an inch below the selected contour for milling. It's the right answer. Passes. There are 2 ways you could do this. You could do this with multiple depths, or you could do this with roughing passes. I'm going to do it with roughing passes. The example part for the Tormach training has multiple depths. That is intentional. If the students run a program that has multiple depths, they probably just ran the example code. Do not give them the credential. They need to run code that they made themselves, and one way to make them do that is by making them do multiple roughing passes, which are not in the example. It's a holdover from a previous version of training that I did, but it's a nice way to see if they're just trying to run the example code, because everyone deserves the opportunity to run code they wrote themselves. The maximum step over in roughing passes needs to be no more than 1/3 of the end mill's diameter. Okay, that means that you shouldn't be taking a cut radially that is thicker than 1/3 of the end mill's diameter. Do I have something round? Pretend this is an end mill. It should only be that far into the material. If it's farther, at the speeds and feeds we chose, you're likely to break the end mill off or have it pull itself out of the holder. And then later on, it'll break off or smash itself in a Z move. Both of those things totally happen. There are failure modes that are perfectly acceptable for a new user. It's a thing that happens sometimes. It is not that big a deal, but it's a hassle because you kind of have to start over. For example parts, let's not get too worried about it. It's worth talking about. If it happens, make sure that you're talking to the patron in a way that says, like, this is a training environment. This is a safe place to fail. These things happen sometimes. What do you need to know to prevent this in the future? Okay, so we're going to do a maximum step over of 3/8 is 0.375 inches. I'm going to round down and I'm going to make that 0.1 inches. And then I'm going to choose the number of step overs. I happen to remember that the stock offset, the amount of stock there is 150 thousandths. So I'm going to pick 3. Some of that time is going to be cutting air. That's intentional. You'd rather cut some air than accidentally cut way too heavy a part. So if you cut it too long on the bandsaw, which is totally a thing you can do, when you go to take your first pass, you'll take way too heavy a cut. We're not going to do that because we're going to use multiple passes. We're going to use roughing passes. There should be 3 step overs at 0.1 inches. For linking, you don't need to change anything. This is all good. We're going to hit OK. And it's going to make these cuts on the side to cut it off. The way that this 3/8 end mill is modeled in the tool library, the flutes are a little bit shorter than they are in real life. I am going to fix this, I promise. But if it shows material above here because the flutes only cut this much, it's going to be okay. The flutes are in there. The flutes that are in there are long enough to cut the whole 1 inch. I know because I bought it. Cool. That's contour. The next thing that you'll need to do, so we've done facing, we've done contouring. The next thing that happens in this training is pocket. Pocket makes an arbitrary shaped hole. Could make a round hole. Could make a square hole with radii. Could make an oblong slot like this. We're going to use it to make these slots. You need to choose an end mill that's smaller than the slot. And we're going to do pocket. It is 2D pocket. Shows this nice pop-up that like explains that it'll cut out. It also says that it's a roughing operation. That's going to become important in just a moment. We're going to use the same 3/8 tool. All the speeds and feeds are good. That's cool. In the geometry, the first thing that you're going to do is pick this hole. You'll notice that the arrow is on the wrong side. So it wants to machine the outside of this. That happens sometimes. You just get underneath here, flip it, and with the arrow in there. The next thing I need to do is set the heights. I want to go all the way through on this one. So the height is minus 50 thousandths. Magic number 2, going all the way through, minus 50 thousandths from the selected contour. In passes, you need to turn off stock to leave. So this is meant to like leave a skin of material on the outside of the part that you then remove with a finishing tool path. These are SoftJaws. It doesn't matter if they have a beautiful surface finish. It'll be okay. Now, we talked about that 1/3 end mill engagement with the outside. The same is true lengthwise. In fact, you can take more side milling, but if you're going to cut with the full width of the end mill, and you're going to because you're going to be like going down into this and at least on one side, cutting the full width as you make that slot, you cannot engage more than 1/3 of the end mill diameter. That is a hard and fast rule for the speeds and feeds in our tool library. It's a good practice generally. That's why I chose it. But for the speeds and feeds in our tool library, which you must use, never more than 1/3 of depth of cut for full width, never more than 1/3 of the end mill diameter for width of cut for full depth. And you can use either, but not both. Great. So we're going to cut full width, so we need to choose multiple depths. And the maximum roughing step down is going to be 0.1 inches. We're going to use even step downs. We're going to hit OK. There we go. And it's going to make this slot. At this point, have everyone finish their cam. There are a couple things they need to do. They need to make this step. We're going to use a contour for that. They need to edit this pocket and add geometry to do the other hole. And they need to make a new pocket that does these counterbores. Have them do this independently. Do not walk them through every step of this. They're going to ask you questions about it. Talk to them about what they're doing. Observe what they're doing. If they're not sure, that's okay. That's why they're in the training. But you want to give them the opportunity to practice independently. So everyone's going to do those independently for a couple minutes. If they're not sure how to do it, it's okay if they talk to each other. It's okay if they ask you. Be helpful. Be friendly. Let everyone practice. They need the opportunity to practice on their own. The only way they're going to learn this is by practicing on their own. And we're going to make that possible by giving them that opportunity in the training. Cool. We have that. Now they're going to make all of them. I'm going to do them real quick in this video so that there's a reference for it. But it's super important that you, as the trainer, make everyone do this on their own. Cool. Okay, here we go. 2D contour. I need to make the parallel slot. Looks like this. I'm going to hit OK. There it is. Cuts it off. I would like to do this before I do the pockets. So you can, one thing that's cool with these is you can grab them and you can drag their order around to reorder them. So I'm going to do a face, I'm going to do a contour, do this other contour, then I'm going to do this pocket. In this pocket, I can add geometry. Got to flip it over. There we go. They're inside there. They're at the same Z height, so I can use the same heights for them, and it will go all the way through. There it is. Goes down all the way through. 50 thousandths below the bottom of the contour. Magic number 2. Great. 2D contour. It's here and there. I'm using the same tool. That looks good. The heights. I don't want to offset from the selected contour. I want this wall thickness. I'm not trying to remove material from there. I want that to be that thick. I absolutely need to choose multiple depths. The maximum roughing step down needs to be 0.1 inches. I hit OK. There it is. Cleans that up. Okay, last. This is new for the training. It's important that you put it in here. We're going to do a 2D facing operation. We're going to do a facing operation not with tool 4. We've already faced it with tool 4. It has a nice flat top surface, but with tool, what number is it? We got to pick it from the library. Tool 7, a 1/2 inch diameter deburr brush. Okay, this thing is a brush. It's not an end mill. You program it like an end mill, but it's a round brush. It looks like a round paintbrush. And it has abrasive grit in the bristles. When it turns, the coolant runs on it. And what it does is it breaks the sharp edges. Hang on, I got to fix the curtains here. I'm so sorry. Okay, yeah. And it breaks the sharp edges of the part, which makes it not sharp, much nicer to handle. It's just like better in kind of every way. Okay, so we're going to do a facing operation with this flat end mill. It'll also like give you a slightly different surface finish, which I think is nice, but it's sort of a non-issue for this part. The geometry, we're going to pick the same geometry, and in the heights, there needs, for the bristles to work, there must be an interference, minus 0.1 inches from the model top. Magic number 3, for the deburr tool, needs to run with a 0.1 inch interference. I'm gonna hit OK. Passes, I don't need, all this is the same. And it just goes over the top. It's gonna look like it machines away material. It doesn't, it's fine. Cool. The parallel shelf may still be a little bit sharp, and while we're at it, let's deburr the parallel shelf. So, okay, this distance needs to be just right, and I don't want to abrade away any of this surface. So the way that I'm going to do this is I'm going to do a 2D contour on this edge. And I'm going to use the same 1/2 inch diameter tool, this geometry. The heights need to be minus 0.1. And then I need it to be inset a little bit so that it actually hits it. Right? So in passes, I'm going to choose stock to leave. I'm going to have 0 axial stock to leave. I want the axial one to be what I did with the heights. And then the radial stock to leave, I'm going to make it negative. So I'm going to make this negative 0.030. I'm going to hit OK. And what it's going to do is it's going to come down around here and hit this and clean up that edge. That way that edge won't be sharp. It'll be really nice to handle. The only sharp edges that you'll have to contend with are down here at the bottom and on maybe on the ends. So this doesn't completely deburr the part, but it does deburr the whole tops. A lot of the top of the part. This is like most of the features are going to be on the top of the part. Makes it a lot nicer to work with. At this point, we are ready to post-process our file. So we have our setup. It has all of our stuff in it. Face, the contours, the pockets, the face, the contour, the deburr passes. And we need to turn this into the text file that the machine reads. So you highlight your setup. I usually do this with a right click. There's also a thing in the command, the toolbar, G1, G2, it's the post-process it. And it brings up this menu. The thing you need to do is make sure that you're using the right post. You're going to select it from the library. And this is cool because I'm going to upload the post. In the cloud, in my cloud post, I'm going to import a post. And I'm going to import Tormach EXP Makerspace.cps. This is the one I want. Oh, it turns out I had done that already, but that's okay. I hit select. And then it will have the name and the number. This name needs to be something that you can pick out of a list of text. There's a comment. There's the output folder. So this points to a flash drive. There's a flash drive in the machine. I'm just going to put a flash drive in my computer. It says there's a problem with it, but it'll still post it. It's fine. Yep. Okay. Cool. Puts in the D drive. You don't need to do anything else here. I'm going to make this the example. Hit post. Stuff happens and it's going to give you this and say view NC code, and then you're going to look at the G code. In the G code, it's going to be the name, the title will be the name of it that you gave, and then it's going to have some comment, right? It's going to list any tools, their minimum Z height. So this is as deep as they're going to go in the part with 0 at the top of your part. And then it will have your different operations. G53 are the machine coordinates. T4, G43, H4, M6 calls tool 4, uses the tool length offset. G43 calls the tool length offset that is number H4. That's the measurement of the tool. So it like offsets the Z for the measurement of the tool. And M6 changes the tool. Then the spindle, M3 starts the spindle at spindle speed of 5539, and M8 turns on the coolant. G54 puts us in that work coordinate system that we talked about before. So when you set your 0 with the probing on the machine, which looking at the timer is going to be a separate video, you need to make sure that they're set in G54 because you're calling G54. That's the reference for this. And then you have all of these G0 moves. G0 moves are rapid moves. They move as fast as the machine goes. You're going to turn your max velocity down to scale those. Then you're going to have G1, G2s, and G3s. G1s are linear movements. They move in a straight line at a programmed feed rate. F13.3 is inches per minute. G2s and 3s are circular moves. They are clockwise and counterclockwise, respectively, I believe. They also move at that same feed rate. So this feed rate is set by the feed rate for the cutting data for the tool. We're going to talk about looking at those as you run the first couple lines of the program. When you do that in the other video, but this concludes the CAD CAM section of the Tormach 1 training. You're almost ready to run the machine. Get psyched. Thanks, everyone. I welcome your feedback on this. Message me, like, comment, subscribe. Yeah, cool. Happy Tormach CNC.